Hey everybody, welcome back to My Physical World, where I talk about anything science. When I am not doing my science, physical science and remote sensing, my remote sensing is analyzing physical Earth processes using Landsat or Sentinel data in a geographic information system. When I'm not making maps and doing analysis, I create scenery for Microsoft Flight Simulator, and I provide all that scenery for free on flightsim.to for other people that have the simulator to enjoy in their flying their airplanes. Yeah, you can say that my Flight Simulator is a game. In an essence, it is. But there are many people out there that use it for training, to get interested in learning how to fly airplanes and things like that. And they need accurate scenery in order to practice. And that's basically what I do. I make airports and things like that, but I also make other landmarks that are interesting. And currently, I am working on NASA's Deep Space Network. And looking at the screen, this is the coverage around the globe of the NASA's Deep Space Network, or DSN. There are 3 complexes equally spaced around the globe. One outside Barstow, California, known as Goldstone, one outside of Madrid, Spain, and one outside of Canberra, Australia. As the Earth rotates on its axis, one complex might get out of line of sight from a spacecraft that they're trying to communicate with it. So during this transition area, they will transition their communication to another station. Okay, so they have continuous communication with spacecraft. All right. The other thing that I do is I use the internet extensively for a lot of the models that I make. And I will find technical drawings, images. I will even try to communicate with people that are on site, and if they're willing to help, will give me information to make my models more accurate. So I currently have some communication off to Goldstone on asking some not security sensitive type of stuff, but information about the scopes that I can't see in some of their images, such as in the case of the 70-meter dish. On the back of the dish, there's a set of staircases that go down to the ground, all right? But this thing rotates on the azimuth right here at this base, okay? This part doesn't move, but this part up here rotates as the telescope is moving on the azimuth, all right? But I want to know if the stairs move with it, or do the stairs stay in place and this part rotates. So some unanswered questions that I like to get from people that are on site of any scenery that I'm using. But in my research, I always find bits of information that is pretty cool. All right. Yeah, I can get information on the size, like the size of this 70-meter dish, okay, which is about 230 feet across. The area of the dish is 41,000 square feet. If you don't understand 41,000 feet, an acre of land is 43,360 square feet. So this dish is almost an acre area. All right. It also weighs 2,900 tons, U.S. tons. That would be 2.7 million kilograms, I believe. So I find some interesting information. Now, each site has different size telescopes. The most popular size that they have at each site is this 34 meter antenna. And if you have a 3D printer and you want a model of this telescope antenna, I interchangeably use dish, telescope, and antenna, okay? But I mean the same thing. But you can download, just do a search, 3D print NASA, and it'll take you to a site where you can download a whole bunch of neat looking spacecraft and things like that. You can print on your 3D printer. So I have one of the 34 meter dishes right here that I'm painting up and put on my shelf for display and things like that. So it's kind of cool. They also have, each site has one 70 meter dish. And these things are, like I said previously, they're gigantic. But this is what I'm modeling right now. I have the 34 meters done, and I also have them animated, so when you go into the simulator, you can see them rotate, and you can see the dish move up and down, things like that. Okay. But the cool thing that I found in my research was the DSN Now. If you go to DSN Now, which is eyes.nasa.gov/DSN, you can see the current communication of each site. All right. So you get the Madrid site, you get the Goldstone site, and you get the Canberra. And it shows you all the different radio telescopes that are currently active. So we see at Madrid, we see that all 5 34 meter scopes are up and running, and these little wavelengths that you see here are the kind that they're actually communicating back and forth. Okay, so currently they have one in Madrid that is communicating with Soho. Okay, and this is DSS-65. Soho is monitoring the sun. And then they have one that is communicating with Lucy and the Chandra here. All right, so, and I believe this is Kepler. No, this is North Korean Pathfinder, which was just launched not too long ago. All right, so you can click on each one of the radio telescopes and find out what they're doing. They're whether, even look at the Earth. So this one is pointed straight up right now. The one that's communicating with Lucy kind of looks like this configuration. The one that is communicating with Korean Pathfinder is in this position. So you can just go from site to site and see what each telescope is communicating with. All right, which is kind of cool. Now there's only one 70 meter that is currently communicating, and that is in Canberra, Australia. All right, and it is communicating with Juno, which is orbiting around Jupiter right now and getting valuable scientific information. You can also note, if you also notice, Canberra is currently communicating with the Mars Reconnaissance Orbiter, which is orbiting Mars, obviously, and communicating with the rovers that are on the surface. So check out eyes.nasa.gov/DSN and go to Deep Space Network now, and you can see the communication that's going on with all the different active radio telescopes. So really, that's all I wanted to show you today, is something cool that I stumbled across in the past few weeks working on these telescopes. So, hey, go to nasa.gov and check out the information on the NASA Deep Space Network. And I hope you found this informative, and I will talk to you guys later on the next video.